Okay, question 5. This question is about electrolysis. Some metals are extracted from molten compounds using electrolysis. Why is electrolysis used to extract some metals? Okay, and it's very simple. When we look at the reactivity series, anything that is above carbon in the reactivity series cannot be extracted by heating it with carbon, so the carbon can displace it because they are more reactive than carbon. So the reason for that is that some metals are too reactive and therefore they need to be extracted with electrolysis. Okay, so that is your answer for that question. Okay, there we have it. Now, next question, question 5.2. Aluminium is produced by electrolysis of a molten mixture. What two substances does the molten mixture contain? Okay, so in this question, question 5.2, aluminium is produced by electrolysis of a molten mixture. What two substances does the molten mixture contain? Well, one of the things that is going to have is the aluminium oxide, because aluminium is found in the environment as aluminium oxide. And the other thing is going to be cryolite, because cryolite is a substance that is added in order to reduce the melting point of the aluminium oxide. Now, you don't need to know how it works. All you need to know for the GCSE sake is that cryolite reduces the melting point of aluminium oxide. So let's write those two things down. Okay, there we go. So can we move on now to question 6.3? Copper and chlorine are produced when molten copper chloride is electrolyzed. So if you get the copper chloride and you melt it and you do electrolysis, you're going to end up with copper and chlorine being formed. Complete a half equation for the reaction at each electrode. Now, this is just 2 marks, but it's such an easy 2 marks that we should not be leaving any questions unanswered. But I'm gonna take a little bit extra time here to explain what is happening, okay? Now, copper is a metal, chlorine is a non-metal, okay? Now, copper is gonna give away electrons, chlorine is gonna gain electrons, and then they're gonna make an ionic compound because chlorine is gonna become negative and copper is gonna become positive. Now, I know that chlorine has a -1 ion, and therefore is going to become a negative ion, the anion, and copper is going to have a positive ion, and in this case it's telling us right here that the ion is going to be 2+. Okay, let's keep that in mind. Once that happens, obviously copper chloride is going to be CuCl2. Now the reason we got 2 here is because the charges don't quite balance. We have 2 positives and 1 negative. Therefore, we need another chlorine to have 2 negatives that can balance out the 2 positives, and that's why the formula is CuCl2. Okay, now in order for this to form, copper would have given 2 electrons, 1 to each chlorine, and they get bonded together. Now, when electrolysis happens, those 2 are going to be broken apart. Okay, and when they go to the electrons, copper lost electrons. So when they get to the electrodes, copper lost electrons, so it's going to gain those electrons back and become normal copper again. And chlorine is going to give away the electrons that it gained from copper to become the normal chlorine. And this is how it happens, okay? So copper, if you had copper 2 ions plus 2 more electrons, you will have copper back to normal, okay? So if the copper in copper chloride, which is C2+, gains the 2 electrons that it lost at the very beginning when the copper chloride was formed, is going to go back to becoming normal copper. Now the same thing applies to chlorine. If you have 2 chlorine ions, okay, you could represent that as having 2 chlorine atoms plus 2 electrons, 1 each, okay? That is the way that it is explained. We have atoms, okay? And if they gain or lose electrons, they are going to become ions, okay? Now, if you have an ion and it loses or gains electrons, it can also become an atom, but it's just going in reverse, okay? So in this case, we have copper, okay? Copper is going to be Cu. If I take away 2 electrons from copper, I'm gonna end up with Cu2 plus, okay? Let's see, how can I do this? All right, so I'm gonna do the other one over here. So chlorine, okay, if I got chlorine and it gains 1 electron, I'm gonna end up with Cl1 negative. Okay, but remember that the chlorine is a diatomic molecule, so you'll never get just the one chlorine molecule atom. You're gonna always have them in twos. So that's why we say if you had 2 of those and you give it 2 electrons, you're gonna end up with 2 chlorine ions, the ones that you see here. Okay, now what we're doing here in this question is that we're reversing it back. So I'm gonna swap this around. So if I go ions to atoms, if I have a C2 plus ion and I give it the 2 electrons that it lost plus 2 electrons, it's gonna turn back into the normal copper. And if I had 2 chlorine ions, that's not negative 2, that's negative 1, because it's negative 1 done twice, and I take away 2 electrons, they're gonna turn back into being a normal chlorine. Okay, that's what we're doing in this question. It's just that it is represented differently. In here, it's telling me that if I have a cation plus 2 electrons, I could have copper again, and if I have 2 chlorine anions, is the same as having 2 chlorine atoms plus 2 electrons, 1 electron each, and that is the whole thing. And that there is an easy 2 marks. You shouldn't be leaving those marks behind. Okay, every little mark helps. Now let's move on to question 5.4. Figure 4 shows the apparatus a student used to electrolyze copper chloride solution. So you got your power supply, your 2 electrodes, your positive electrode, your negative electrode. Copper chloride solution is over here, and then the electrodes are made with pure copper. The student measured the mass of copper deposit on the negative electrode after 60 minutes. Compare the mass deposit with the expected value. Suggest 2 reasons why the mass deposit was different from the value expected, or the expected value. So here we go. Okay, now what we got to look at here is that from the copper chloride solution, okay, from here you are gonna have Cu plus, because the moment they are this is a salt, copper chloride, so that's gonna be the copper chloride. Okay, that is a salt. Once you put it in water, because remember we said that solution means that something has been dissolved in water. Okay, so from here, once you mix the copper chloride into the water, you're gonna get the following ions. You're gonna get Cu pluses, you're gonna have Cl minus, you're gonna have from the water, you're gonna have H pluses, and you're also gonna have OH minuses. Okay, so now we have 2 positives competing with each other to go to the negative electrode, and then you also have 2 negatives competing with each other to go to the positive electrode. Okay, they're going to be attracted to the cation, to the cathode, and they're going to be attracted to the anode, which is the positive electron, and that's going to be the negative electron respectively. Now what is going to happen is the copper is going to be attracted to here. Okay, now the student is measuring the weight or the mass of that electrode made of pure copper, and after the experiment, when the copper has attached itself to it, is going to measure the weight again to find out how much it increased by. Okay, but there is a database that tells you how much it should have increased by, but when he did his calculations, it didn't match. Okay, so the question is asking you, give 2 reasons why it didn't match. Okay, so any of those two reasons would have been that the concentration or the volume of the solution was different. There might have been impurities in the solution. It could have been an error in the timing. The copper falls off the electrode because as it attaches in there, some of it can drop off to the bottom of the container. It could be the copper was removed when drying the electrodes. Once you take it out, you want to remove the excess liquid that is attached to it. Some of the copper might have fallen off. Then the electrode did not dry. That means that it weighed more because it was wet, or the voltage of the current was different from the original experiment, and therefore there wasn't enough energy there to make that happen. Okay, so any of those things will give you an answer. So I'm going to write those down right here. Okay, any of those will give you the marks for that question. Okay, let's move on to question 5.5. Figure 5 shows the expected mass of copper produced each minute. So it is a linear relationship. As you increase the time, the mass of copper also increases at the same proportion. So that's why you get a straight line. So it says determine the expected mass of copper after 24 hours. Okay, use figure 5. Now this is pretty simple. All we have to do is make sure we are using the ruler, and then we can actually work out the values properly. Okay, now you will get about half a square of tolerance in the graph of the squares, simply because they're very tiny. But first of all, you need to find where the what's it called, 24 hours is going to be. So this is your time in minutes. So if 30 minutes has this value over here, 30 minutes has that value. Okay, so we're gonna mark it with 30 minutes. Now if we move across with the ruler, that is going to take us, and that's probably going to be halfway through that square. That's going to take us here. We need to find out what that value is. Well, that's dead in the middle of 5 and 6. So I can say that that is maybe a 5.5. Okay, that is 5.5 milligrams every 30 minutes. So all we got to do now is find out how many 30 minutes we have in 24 hours, and then multiply the 5.5 times that number. Okay, and that is it. But in the mark scheme it says 5.4, but it gives you a tolerance of half a box. We got 5.5 in this question, so it should still be alright. And as long as the rest of the calculation makes sense, it should be okay, and you should have full marks. Okay, so if I do 24 hours times 2, and I'm doing times 2 because in each hour there are 2 half an hours. Okay, and that's gonna give me 48. All I have to do now is do 5.5 times 48, and that's gonna give me my answer. So 5.5 times 48, and I have an answer of 264 milligrams in 24 hours. Okay, that is what I have here. And 264, again, it's not asking me for significant figures, it's not asking me for decimal places, so just the 264 is absolutely fine. Let's go to question 5.6. Okay, silver nitrate solution is electrolyzed. Figure 6 show the change in mass of the negative electrode over 10 hours. Okay, determine the mass of the negative electrode at the start of the experiment. Use figure 6. So what was the mass? Let's see. Now if we're looking at this, we have that right there should be 2.5, which tells me that 1, 2, 3, 4, 5, each one of those squares has an equal of 0.5. Each one of those squares is 0.5. So when we look at this, determine the mass of a negative electron at the start of the experiment. When we have 0 time, we need to find out how much this was over here, okay? And that is giving us 2.5, 3, 3.5, 4, 4.5, and then it's on a half of that. So I would go for 4.75. Okay, that would have been the mass at the beginning, and we gotta write down those grams. Okay, now the next question, it says calculate the gradient of the line in figure 6, give the units. All right, so for this here we're going to need the gradient is the change in y over the change in x. Okay, all we need to do is find those two values and do the substitution. So if we look at over here, all right, there we go, we're gonna bring this down. There we go, and then from here we're gonna make that triangle, and we already know that this is at that point here. Okay, so the change in x, because this is your x-axis, okay, is going to be from 0 to 10, so that's going to be 10. At the bottom here, change in x, we're going to write down 10. Now the change in y, which is your vertical bit, all we got to do is find out how much is this at its very top. So I'm guessing, well, not guessing, I'm looking at this, and this here ends up in half of that square. So this here would be 6.75. That's what this is ending up. So all I gotta do is do my 6.75, take away 4.75, and that gives me 2. So my change in y is going to be 2. Now I only have to divide those two there. So I'm going to do 2 over 10 equals 0.2. 0.2, and that is my gradient over there. The gradient is 0.2, and the units are going to be grams per hour. Okay, and there you have it. That is question 5.7. Hope you enjoyed that, and if it's helpful, carry on and move on to question number 6. Thank you very much. Right, so there you have it. Quick time revision. Like and subscribe, and I'll see you next time.